I like to think of a bicycle wheel as a circular arch. You'll probably not see that kind of a description anyplace else, but let me show you what I mean. And you all know that the Romans were famous for building arches, and they are marvelous structures still standing today. At the top of an arch is something called a keystone. The job of the keystone is to take a vertical downward load and to distribute it along the sides like that. And let's examine just that piece of the arch right there. So here we are just looking at the stones in the arch. We'll make a copy of that arch. We'll flip the right side upside down. And suddenly we have a representation of a circular arch. The circular arch can spin. As it does, it morphs into a bicycle wheel. My bicycle wheel is really a large number of imaginary keystone-shaped pieces that are being pulled together toward the hub with the force of the spokes. And there is one of those little keystone pieces right there. You can see here that the spokes are pulling the rim in on itself, and the resulting strength of the wheel is huge. We can get one more bit of information from these graphics. The wheel shown there is a wheel made from a deep section rim, so each of those keystone pieces is pretty large, and the wheel will be correspondingly very strong. If we look at the wheel on the right, we see that it's a wheel made with a little bit narrower or less deep section rim, so I can still make a strong wheel, but it's not going to have quite as much strength as the one on the left, everything else being equal.